Hi, my name is Rance and I'm a third year comp sci student at McMaster. I'm currently on co-op at ECCC, Environmental Climate Change Canada, working on the IMWEBs app. So IMWEBs app is a cross-platform desktop application for exploring and analyzing different environmental data sets. So what is IMWebs? What is our objective? Our objective is mainly to allow users to simplify the visualization and analysis of tables, graphs, and maps using databases, shapefiles, and TIFF files, raster data. So our main support is about it's a class for platform app, meaning packages are available to be downloaded from for Windows, Mac OS, or Linux, and we also have charts and maps inside the app. Finally, we have easy to export for tables and graphs, CSV, XLS, text, PNG, SVG, or PDF. And for maps, we have shapefiles and PNG as well. And finally, we use Makefile and PowerShell scripts for CI/CD development to improve the build process, and automate it. Moving on to our system design, we have the front end, back end, and Tori, which glues together the front end and back end. Pages like graphs, maps, tables, login authentication for our web app is our main component for the front end. And we build the front end using Vite. Finally, backend is the heavy lifter that does all types of receives all types of requests from front end and sends data back to front end, so front end can display them as tables, maps, or graphs, and all types of data fetching or transformation logic and export authentication that backend handles it. And Tori is the glue, like I mentioned before, and it combines backend as a sidecar and front end as their main one, where the front end runs and the backend front end sends requests to the backend, and backend sends the data for front end to be displayed. Moving on, I will showcase our main page where we have panel one, which is about a folder, which is our main test model folder that comes with the Amazon app, which has geospatial shapefiles and TIFF files. Only shapefiles, TIFF files, and DB3 files will be displayed. And clicking on a DB3 file, you can expand for table selection. You can select multiple tables. And we have second panel where we have the parameters. If we click one of the tables, then the parameter will load here, and we can click one of the parameters to select them. Finally, we have the display for settings display at the top here. We have the model start date, model end date, and interval. These are just for letting the user know what it is, and this is for selecting IDs, start date, end date, and this is for export selection. Same with export select columns, which is only for export, meaning select columns to export columns is the same, but export columns to select columns is not the same. We have the interval, meaning daily, monthly, yearly, or seasonally. And we also have method conversion and statistics, which are pretty similar, only that when we select the interval greater than daily, we have to select method conversion. Finally, we have the export path for the local app, which is default, and file name and export format. Only table has CSV and text so far. We have our export table and our stats, where when we are selecting statistics or method conversion, we can select to export table and stats or just one of them. And we have the fetch data button or export data button, which fetches data to load here, export to files. And finally, we have our main view, where the table loads, or the graph will load, or the map will load. Moving on, let's show our table or project where we can showcase tables with statistics as well. We will select all possible columns for now, and just one like zero ID. Users can select more. It's faster to load just for a single ID as well. As you can see, we have all these values for time, ID, and all of them. And for daily, if you want some type of statistics for all of them, even standard deviation, we can do that by clicking here. And we have average, maximum time, meaning when maximum is, the time at maximum, and the time for minimum, and standard deviation. Finally, we can move on to interval. Intervals greater than monthly can be selected where it shows a pop-up, meaning you at least have to choose one of the method conversion for interval to work. As you can see now, the time is only months, and the year and the month, and the day, the values are added up monthly. And you can add more for method selection, but average is now fine for now. Yearly, and it's just years from 2016 to 2022. And finally, we have seasonal. This seasonal for each year, and seasonal is monthly with the season column added, and also the average for the season. Fine, let's go back to daily, and we will export to a shapefile. I mean, sorry, not shapefile, CSV. And to export to a CSV, let's say we want some statistics for daily. Let's add all statistics for daily. And when we add statistics, we also need to select stats here, as done only it will export the stats to the table. Now we can see our exported table in a default location, which also showcased in the help page, where the IMWEBs viewer is loaded. And then we can go to this page and then, sorry, this path. And since it was data export, it will be saved in data export. As you can see now, we have everything saved with ID and everything. And finally, we have the statistics at the bottom. We can also save to monthly. Once again, we have to select at least average, but and we can also add stats. You actually don't need to fetch data again. You can directly export. As you can see now, it's monthly for each year from 2021 month. And we can also showcase daily, just export. This is for yearly, and the statistics for yearly. Moving on to our graph page, we can now load reach nutrient concentration. And we have to select the x-axis and the y-axis, all the extra values. We'll choose some small values and some big ones for in total p loading. And once again, we'll only choose 0 ID, so it's faster to load. And finally, we have different types of graph types: bar, line, scatter, and we can choose them ourselves, but scatter default would be best. As you can see, if we hover over them, on the left side, we have some values less than 100. The other is on the right side, we have values greater than 100. And we can zoom in on some values using our mouse scroll. And we can also zoom in or like reset everything again. Now I will export it to a PNG, which will be similar to this. As you can see, on the left side, we have values less than 100. On the right side, values greater than 100. And we have the x-axis and scatter. We can also export to a graph in Excel. So it will load Excel values, meaning it will have all the Excel values ready in the Excel, and it will automatically generate a graph for you as well. As you can see, similar to what we have, values, smaller values and the larger values with the x-axis, and it's for time and all these columns except ID, as they are categorized according to ID. Now we can load monthly, and as we can see, monthly is a lot smaller compared to before. The values are not as populated, and same for yearly. Yearly is even less populated. And let's try exporting to a PNG to monthly. As you can see, these are values for monthly, which are very similar to this. Moving on to our map page, we will just showcase a simple combination of shapefile and raster data. As you can see, when clicking Fetch Map, we have polygon color, line color, point color, and their opacities, which the user can customize. And these three things, I will be getting that to them when we combine shapefiles with database tables. So we have our polygon. When we hover over the polygon, we can see that the attributes from the .dbf files combined with the shapefiles for the polygon. And we have the TIFF or legend, where the smaller values are darker and the higher values are lighter. Moving on to combining shapefiles with database tables, we will go to our subbasin shapefile and combine with subbasin nutrient. And we will be working with TP runoff only, and we'll select all IDs for now. Finally, we'll be getting onto our selected feature. Our selected feature is the first selected feature that was selected, which is TP runoff. And based on this feature, the polygons will be colored also based on the data. So it combines the data's values and colors the polygon based on those values. And it based it on average, some minimum or maximum. We will choose average for now. And it shows selected spatial scale as the shapefile was named subbasin. As we can see, it loaded the polygon and colored it, filled the color with different values based on this legend. And since it's TP runoff, it has its own scale. And also the borders are thicker for bigger values and thinner for smaller values. And let's say we just click on this FID 86. So it's going to load the table for 86 and all the TP runoff values. They're higher than all the others. And also load the graph as well. And now we can also load it for monthly. As you can see, the monthly values are higher than the daily averaged, as it's added for each month in 1 month. And we can do the same for yearly. Once again, as you can see, the yearly values are higher, but the coloring still remains constant to what it was for daily. And moving on, we can move on to a subarea shapefile, combining with subarea nutrient. And for this, we will also be using TP runoff. And we will, from moving on, we'll only be loading daily. As you can see, the selected spatial scale got updated because the shapefile is named subarea. And if the shapefile was not named that, I would suggest the user to manually select the spatial scale. And we have our shapefile with the colorings. And now we'll be using the same database table, but with field. The same TP runoff. And this time it automatically also selected field. Even though the database table is the same, the coloring will be very much different. And there we have it. As you saw it, the database table was still the same, but the colorings were a lot different for field values, as fields have an extra logic going on in the backend that differs from subarea. And now we'll be choosing our streams, which is also a reach and channel sediment balance and sediment out. So this time our shapefile was not named anything, so we have to manually select reach, and reach is the only one that are lines. Uh, so they will be different compared to polygons, but they're also thicker for bigger ones and thinner for smaller ones. So you can see the black one is thicker and the wider one is thinner, according to these values. Finally, moving on to our final component, which is a calculator. We'll be using subbasin with subbasin snow water balance, and the columns that we select, except time and ID, in which order, that's how the calculator calculates the formula. So we're going to choose total runoff and groundwater runoff. So we have our auto mode and a manual mode. A manual mode is just like selecting a calculator, multiplying by numbers, dividing by another column, or multiplying, adding. Anything is just like a regular calculator. Auto mode, we cannot select columns. We just can multiply by numbers, changing the orders of column, or we can just add, subtract, multiply columns. So we're gonna subtract column. So in the order that we select, we chose total runoff first minus groundwater runoff. And the selected feature is not selected. It will automatically be selected soon. And there we have it, or R minus RG, which is total runoff minus groundwater runoff. And now we can export as a PNG. So what I would do is take a screenshot of this and save it, and another image as well. And we will also export our files with the R minus RG to shapefiles. For export to shapefiles, it saves that the shapefile name, the interval, the feature, R minus RG, and finally means, since we have been choosing average. Now let's compare the shapefiles. No, first let's load the image that loaded. So it was a screenshot of our current page, and another is just a regular screenshot, a regular PNG of the polygon subbasin. Now we can compare the shapefiles in QGIS. As you can see, it's the same as our polygon here. And if we see some attribute tables, we see R minus RG values at daily and mean. For our final calculated demonstration, we'll be using subarea and subarea nutrient loading with TP runoff minus organic P runoff, and this is our polygon. Finally, moving on to showcasing our web app, which is very similar to our desktop app. Only a few differences would be mainly three differences, which is one of them is login, where we have to sign into the app. And you can contact admin for password, and it will send us an email, Dr. Liu and Dr. Wang and me. And finally, we have the help. If you're having trouble with the website, just click here and you can install the desktop app. Another second difference would be selecting folder. As a selected folder, we're uploading the model folder containing two files to the server, and it sets that model folder as our main folder now. And value. And the values are loaded. The third and final difference would be exporting. If it's a single export, then it will just send a CSV or text file. And if it's a bunch of multiple files, then it will send a zip file only. So right now we're only exporting CSV, so it will only send CSV. And there we go. Thanks a lot for watching, and I hope you enjoyed it.